26.3 Beth Gates. Introduction. VO2 max is defined by Adams et al. 2010 as the maximum amount of oxygen that can be taken in by and be utilised by the body. In other words, it is your maximum oxygen uptake. VO2 max has a direct relationship with exercise intensity. Oxygen uptake increases linearly with an increase in exercise intensity. When you reach your VO2 max, you begin to work anaerobically and use your glycolytic energy system, as you can't consume any more oxygen per breath. This is shown in Figure 1 by the plateau on the graph. Henceforth, when testing for VO2 max, this plateau can be an indicator that they are working at their VO2 max, and therefore can be used to determine whether they're testing accurately or not. There are both health reasons and sport reasons to measure VO2 max. VO2 max can be an indicator of cardiovascular health. Henceforth, it can indicate whether you are at risk of heart disease. According to Allison et al. 2005, the best predictor of survival in cardiac patients is their capacity for exercise. Henceforth, VO2 max can be used to predict and monitor heart disease. It would be suggested that a larger VO2 max would indicate better health, as it has a correlation with heart rate and stroke volume as well as breathing rate. A better VO2 max means you don't need to work as hard to pump as much blood around the body, because there is more oxygen being transported in each breath or heartbeat. To sum it up, having a better VO2 max means that you can work harder with more ease, making daily tasks a lot easier because you don't need to work as hard to have the same outcome or effect. VO2 max can also be used in sport to determine things such as training zones, fitness levels, and suitability for sports. So it can be used to determine thresholds and gauge intensity due to the direct relationship between the two that was previously mentioned. So this is beneficial for training, as you may wish to work in a certain zone or intensity. For example, if you want to work anaerobically, you would work in a different zone to if you were working aerobically. VO2 max can be an indicator of that and allow you to work within those zones based off of your VO2 max. Additionally, at the start of a football season, for example, teams run a medical screening on their players to ensure that they're fit enough to play. This is to prevent health issues as a result of poor fitness. So VO2 max is one of those indicators that is looked at in those medical examinations pre-season to determine whether they are fit enough to play. Finally, events such as marathons or long-distance runs require a high VO2 max. Therefore, if someone has a high VO2 max, they may be suited to events like that. VO2 max could be used as a talent indicator, suggesting what sport that individual may be suited to. So this can be seen in Figure 2. You can see in Figure 2 that cross-country is at the higher end of the spectrum, where they have a larger VO2 max. Cycling is also up there, and rowing is sort of middle, and lower down you've got things like cricket. This is because things like cross-country, they require a lot more aerobic respiration because you're working aerobically for a longer period of time than things such as cricket, where perhaps you don't have to run around as much. Therefore, cricket doesn't require as high of a VO2 max. So someone with a high VO2 max might be suited to cross-country or long-distance running, as they already have that initial high capacity to start with. So it might be seen that they should pursue a career or pursue performance in that area. There are two different ways we measure VO2 max. There's an absolute VO2 max and a relative VO2 max. The absolute VO2 max is a measurement in litres per minute that doesn't account for the individual's body weight. It's simply a direct measurement that doesn't account for any other factors, such as that body weight. Whereas the relative VO2 max does take body weight into consideration, and is a measurement in milliliters per kilogram per minute. Relative VO2 max is often the one used to compare the performance of different athletes, as it shows a fairer comparison based on their body weight, whereas if it wasn't based on body weight, it would be unfair, as you might have shorter athletes who have that initial disadvantage, as they initially have smaller lungs, whereas you might have a taller or larger stature athlete that has that initial advantage. So taking weight into consideration makes it a fairer playing field and shows a fairer comparison, which is why it's often used to compare two different athletes directly. Absolute VO2 max would be just as suitable if you were comparing one athlete, so perhaps checking their progress over time, because obviously their body weight may change, however, it's still the same athlete, so it's a fairer comparison. However, obviously, relative is probably seen as the most suitable if you're cross-comparing different athletes or individuals. As well as different sports or events affecting VO2 max, age and gender are also factors that can affect this. It's a general trend that males have a naturally higher VO2 max due to the physiological advantages that they are born with, for example, bigger lungs. Additionally, as you age, your VO2 max begins to deplete. This is due to the physiological changes that occur with age. Your muscles begin to weaken, and this includes your heart and your intercostal muscles. Henceforth, normative values for VO2 max vary dependent on age and gender. These differences can be seen in Figure 3. Figure 3 shows data for males and for females, and then looks at different age groups within that. You can see that males have a naturally larger, the trend is that they have a larger VO2 max than females. In terms of testing for VO2 max, there are both indirect and direct methods of measuring. There are also maximal and submaximal tests. A direct measurement, such as gas analysis, using the Douglas bags, takes a direct measurement of the oxygen used by an individual. Indirect methods estimate VO2 max based off of the correlation between heart rate and VO2 max that I'd previously mentioned in Figure 1. Therefore, direct measurements are seen as more reliable and more accurate because it quite literally takes a direct measurement of the gas and analyses that, whereas the indirect methods are based on estimation, so they're perhaps seen as less reliable and less accurate. Maximal tests push participants to work at their maximal capacity and to the point where they can no longer physically continue. Submaximal tests do not do this. They simply have participants working at a steady rate to see the effect on heart rate. For example, the Queen's College Step Test. The gold standard test is gas analysis, for example, that previously mentioned Douglas bag test, as it takes a direct measurement of the gas and analyses that and breaks it down into oxygen consumed by the individual, which allows you to determine VO2 max. A study by Lima, 2005, looks at the protocol and therefore the validity and reliability of that based off of the protocol. In this study, the individual is quoted to have connected to a metabolic gas analyzer. So this is similar to those Douglas bags, through which the gas samples were collected and measured. So in this study, they were measured every 10 seconds during the test. This means that they have consistent measurements throughout the test to show the continual trends throughout the whole test, and to show how perhaps the VO2 max rises and falls, or where the VO2 max is at. This makes the test a lot more reliable as you're getting consistent measurements throughout the test, and it allows you to see more of a trend from the test, if there is a trend at all. In addition to this, a ramp protocol was used in this test, which basically increased the intensity of the exercise until they hit a peak where they couldn't physically continue anymore. That would be consistent in any type of VO2 max gas analysis testing, because it's part of the criteria is to hit their peak VO2 max consumption. Using the gas analysis as well as RPE, which was done in this test, actually enables you to establish when they are at their peak level of exercise or intensity where they can't physically work anymore, which is part of that criteria and enables you to get an accurate result of their VO2 max. In addition to this, there was also criteria for this test by Lima in 2005 that there should be an establishment of a flat on the oxygen intake curve in relation to the load. The criteria considered should have been also gas exchange ratio of more than or equal to 1.0, physical exhaustion, or indirect VO2 max measurements. There was a list of criteria for this testing, which made it even more accurate and more reliable, because there's a certain criteria that has to be fulfilled for it to be an accurate consumption. Therefore, if there was to be retest, it would be very reliable because there's a certain criteria that has to be met, as according to this study by Lima, 2005. Contrasting to this though, a study by Gore in 2003 looked at this Douglas bag testing also. However, they looked at different versions of the Douglas bag testing in comparison to more recent methods that used computers to analyse instead of those just those Douglas bags that was established earlier on. So Gore states, the Douglas bag method collects a fully mixed sample of expirate in a single bag, whereas newer systems often adopt the breath-by-breath approach that was pioneered by Beaver and colleagues. Critical to this approach is temporal alignment of the ventilation measured at the mouth with the associated gas fractions that are subsequently transported from the mouth to the gas analyzers. So basically what that is saying is that newer methods are more reliable in terms of the breath-by-breath approach, as it allows you to analyse each breath individually rather than just a collection of breaths. So it kind of allows you to look at the different stages and different approaches throughout the whole exercise. However, the newer methods, there are issues with reliability in terms of lining up the actual mask themselves, which or mouthpiece itself, which analyses the gas, which could mean some of the expired gas doesn't go into the bag. So there are issues with reliability in terms of that. So that whole study just looks at the difference between those methods and basically says that although there are potentially more reliable methods now, often a lot of those methods are compared to the Douglas bag method because it is so reliable and because it is that gold standard method that has that high accuracy. Overall though, the Douglas bag gas analysis is seen as the gold standard because it takes a direct measurement of the gas and therefore a direct measurement of VO2 max. It has specific criteria that you have to meet during the testing to ensure that you are hitting that peak intensity and that VO2 max. It's most accurate because of that direct measurement of the gas, and it works people at their maximal intensity. It is a maximal test that pushes them to work their hardest. So it's probably more tailored to sports performers, as they can push themselves to their maximum, whereas perhaps it might not be as suited to the general population. It's not as accessible for one, and also perhaps like the elderly or those who have health issues might not be able to push themselves to their maximum. So perhaps it could be seen that although it's the gold standard, it's perhaps not most suitable for everyone, and it can't be used on everyone.